You've seen it, right? You head out to a lake or a pond in the middle of summer and it's turned this murky, gross green color. Well, that's the environmental puzzle we're going to try and solve together today. And believe me, it's one that has had scientists scratching their heads for decades. So, let's dive in. Now, some of you might remember this. Back in the 70s and 80s, there was this huge push to get phosphorus out of our laundry detergents. It was supposed to be this massive win for clean water. But here we are. It's decades later, and those toxic green algae blooms, they seem to be getting worse. So what on earth is going on? What did we miss? All right, to figure out why those old solutions didn't quite work, we've got to get on the same page about the science behind this green menace. Okay, the fancy scientific term for this whole process is eutrophication. But here's what it really means. For algae and freshwater, phosphorus is like a super fertilizer. So when too much of it gets into our lakes, it triggers these huge explosive algal blooms. And this isn't just ugly. We're talking about blooms that can produce toxins that are dangerous for people, for pets, and create massive dead zones in the water where fish just can't breathe. And you know, what's so frustrating is that we have been trying to fix this for a long time. I mean, we've spent billions upgrading our water treatment plants, we did the whole detergent ban, and we've been working with farmers on better ways to manage their land. We've thrown a lot at this problem. And yet, the problem is still here. From the Great Lakes, like Lake Erie, all the way down to your local pond, these green blooms just keep coming back. And sometimes they're even worse than before. So clearly, our whole understanding of the problem was missing a piece. There has to be some kind of hidden factor, a ghost in the system that we've been completely overlooking. To find this ghost, we've got to put on our detective hats. And our first clue? It's buried in the past, in over 100 years of phosphorus history. So if you look back, the story really breaks down into two completely different eras. Before World War II, things were pretty steady. Most of the extra phosphorus came from good old-fashioned animal manure. But after the war, everything changed. We kicked off a massive fertilizer boom. The amount of extra phosphorus we were dumping on the land tripled, hitting an all-time peak in the late 1970s. We've gotten a little better since then, but that surplus is still way, way too high. And you can really see the scale of that change right here. I mean, look at this. We went from adding about 6 kilograms of extra phosphorus for every hectare of land to over 15 at the peak. And even now, we're still sitting at around 11 kilograms. That's almost double what it was before the boom. So the big question is, where did all that extra phosphorus go? And that question, my friends, brings us to the big reveal. The culprit we've been hunting for finally has a name. Let me give you an analogy because it makes this whole thing click. Imagine our entire landscape, all the farm fields, all the soil is like a giant bank account. For decades and decades, we were making these huge deposits of phosphorus, way more than the crops could ever spend. Now, that bank account is completely overflowing. And even if we stopped making big deposits tomorrow, the account is so full that just the interest, the phosphorus that's slowly, constantly leaking out, is enough to keep polluting our water for years. And that is our ghost, legacy phosphorus. It is all the phosphorus from the past that has built up year after year in our environment. It's locked away in the soil, it's buried in riverbeds, it's sitting in reservoirs. It's literally the pollution from our parents' and our grandparents' generations, and it is still haunting our water right now. You want the smoking gun? Here it is. Scientists did the math, and they figured out that of all the extra phosphorus we've added to the land since the year 1900, a truly staggering 96% of it is still there. It never went away. It never left. So where is it all hiding? Well, a little bit is in landfills, and a bit more is trapped in reservoirs and the bottoms of rivers. But the vast, overwhelming majority, we're talking almost 90%, is locked up tight in our agricultural soils. Our farmland has basically become this massive accidental phosphorus storage tank. Okay, so at this point you might be thinking, how can they be so sure about this? How did they actually track 100 years of invisible pollution? And that's a great question, right? Because it's not like you can just go out with a tool and measure it across an entire landscape. It took a whole new way of looking at the problem. They built this incredibly powerful new computer model, and they called it Element P. Honestly, the best way to think about it is like a time machine for nutrients. It lets researchers go back and reconstruct over 100 years of history, all the changes in land use, in fertilizer, and population, to see exactly how phosphorus has moved around and built up over all that time. And what makes this model a total game changer is that it's not just simple math. It's not just what goes in must come out. It actually simulates all the complex biology and chemistry of how phosphorus gets stored in different spots, like in the soil or in a reservoir. And this is the crucial part, it has a memory. It knows that a field that was farmed for 50 years is going to act very differently than a patch of pristine forest, even if on the surface they look the same today. Okay, so now we know. The real bad guy here is this massive bank of legacy phosphorus that's been hiding in plain sight. Which, of course, leads us to the most important question of all. What in the world can we do about it? Well, the researchers used their fancy new time machine to look into the future, and the results are, well, they're pretty sobering. If we just keep doing what we're doing, business as usual, the pollution actually gets 12% worse over the next few decades as more of that old phosphorus leaks out. Now get this, even if we get super aggressive and slash fertilizer use, pollution still goes up a tiny bit. It is only when we go completely all in, tackling every single source from every angle, that we finally see a real drop. So here's the hard truth of it all. We absolutely have to cut the new sources of pollution to stop digging the hole deeper. But even that is not going to be enough to fix our lakes on its own. Not quickly, anyway. The ghost of past pollution is just so big that it's going to keep haunting our water for decades, no matter what we do today. There is no quick fix. But it wasn't all bad news. The research did uncover a surprising glimmer of hope. The model showed that one of the single most effective and most immediate actions we can take is just better manure management on farms. Simply stopping runoff from manure storage can have a faster, bigger impact on water quality than almost anything else we can do. So in the end, the main takeaway here is crystal clear. If we want to heal our water, we have to do, well, everything. We need more efficient fertilizer use, we need that better manure management, we have to keep upgrading water treatment, and we have to find better ways to stop our soil from eroding into rivers. It has to be an all-in, long-term commitment. And that really brings us to the final thought here. We've just seen how decisions that were made almost a century ago created a problem that we are still fighting with today. That legacy is real. And it really makes you think, the choices that we are making right now, today, about how we manage our land and our water, those are the choices that will decide how healthy our lakes are for generations to come.